Okay, so we're going to take all this information. We're going to break it down to each piece. We'll start with A part. A tells me to find the domain. So what is the domain? It's all possible x values. So when I look at this graph, what's the lowest x value the graph takes on? No. Okay, so we're going to read this from left to right. So when I look, the graph has a beginning right here. Right? It doesn't go any farther left than this point. That's as far left as the graph goes. I know that because there's no arrow. So the lowest possible value of my domain is -1. Now, is -1 part of the domain, or does it just not include that? Well, because it is a colored in point, right, a closed circle at -1, that means -1 is included in the domain. Now, starting here, as we move to the right, what all x values does the graph take on? Well, look, there's no gaps. It's taking on every x value from -1 to 0, all the way to 2, 3, and then my x's stop here at 4. And it never goes any farther right. So the greatest x value the graph takes on is 4. Does it include 4? It does not, because it's an open circle at 4. So we go all the way up to 4, but don't include 4. That means I put a parenthesis at 4. Any questions about finding the domain here? So we've been doing domain already, so that should be kind of familiar. The only thing we're doing different now is finding the domain for ourselves on this graph. Okay, I'm going to go ahead and do C part because to me, they're one and the same. So I need to find the range of this function. So the range, we're looking at the y values. So what is the lowest y value the graph takes on? Down here at -5. It never goes beneath -5, but it does include -5. So the lowest range value is -5. And then as we increase in y values, what's the highest y value the graph takes on? 4. It goes all the way up to 4. It doesn't get any higher than 4. Is 4 included? It is. So we should put a bracket around 4. So now I found A and C. I found the domain and I found the range. Now B part tells me to find what is the function evaluated at -1. So what are we doing? This is like our f of x, right? Except now my x value is -1. So I go to where my x value is -1, and I want to know what's the y value at -1. If I plugged in -1, what y value do I get? Well, the graph at -1 has a y value of -5. So the function evaluated at -1 is -5. Secondly, it tells me to find the function evaluated at 2. So now I'm going to go to where the x value is 2. Here, what's my y value at 2? It is 4. So the function evaluated at 2 gives a value of 4. On the book, it doesn't put arrows. But because there's no point telling me that it ends at the end, we're going to assume every time that there are arrows, which means the graph continues in this direction indefinitely. So even though we don't see them, that's what we're looking at there. All right, so we should be finished or close to it. Because this is a kind of hard problem, I'm not going to make one of y'all do it. I'm not calling you out, so you got lucky. So A part, finding the domain. So what's the lowest possible x value the graph takes on? Well, because there's an arrow that this continues forever, even though it really doesn't look like I'm moving very far left, I am continuing to move left forever. Right? This graph just barely moves left. Because if it didn't move left, if it went straight down, then I would not have a function. Because it would touch the graph in multiple places. But I know it's a function, so I know it continues to move left, even though it's just barely. So the lowest x value the graph takes on is -infinity. So even though I can't see it, I know the graph keeps going forever in this direction, way over here to -infinity. So now I'm walking along. When do I encounter a problem with this domain? Right here at -3. At -3, I have a hole in my graph. Negative 3 is not included in the domain. It's an x value that is skipped. Okay, so when I look at my domain, from negative infinity all the way until we get to negative 3, I'm good to go. But at negative 3, I've got a problem. So I need to skip it. So from negative infinity to negative 3, my domain works fine. And then that's not the end of my domain, though, because my domain keeps going. At negative 3, right after it, we pick back up. And we keep going, and we're fine. We're fine. My x's are going, x's are going, x's are going. No problems, no problems. I've got another point here, but it's filled in. So it counts, and my x's are good the rest of the way. So from negative 3 all the way to infinity, I have no problems. So the domain of this graph is from negative infinity to negative 3 and from negative 3 to infinity. Questions about that part? Like I said, that's a little tricky. Again, I'm going to do C part next. I'm going to find the range. So now think about the y values. What's the lowest y value the graph takes on? Negative infinity. The graph is all the way down here. It's still happening, even though we can't see it. So the lowest range value is negative infinity. And now let's look at what happens with my y values. So I'm going up, I've got no problems, got no problems. But I've got a hole right here at negative 6. So does the graph ever take on a value of negative 6? Yeah. It does. It still does over here, right? Negative 6 is included in my range here, even though it's not included here. Because that y was supposed to happen twice, then that means I'm good to go. There is no problem at negative 6. So I keep going, looking at my y values. It's taking on every one of them. And then my y values stop. They don't go above this. So the highest y value here is 3, and it is included. So I need to put a bracket around 3 for the range. And now two things. I've got to find the function evaluated at 0. So that means when my x is 0, what's my y value? 3. And then I need to find the function evaluated at 3. So when my x value is 3, my y value is negative 6. Okay, so this tells me to find the domain and range of my function. And this time, I don't have a graph necessarily. Now, we can find the graph and use it to find the domain and range, but we're going to show you how to do it if you did not have the graph. So again, when I'm asked to find domain of a function, I assume it defaults to all real numbers. There should be no reason I couldn't pick an x to work in that equation. But there are two examples, or there are two exceptions where I can break math. I cannot, what are they? What are the two things I'm not allowed to do? Divide by 0 and negative underneath the square root. Could one of those happen here?
Yes.
They could. I could take the square root of a negative. So to make sure I do not take a square root of a negative, then I'm going to say what's underneath the square root cannot be negative. That means it has to be greater than or equal to 0. Then when I solve this, this tells me x must be greater than or equal to 4. So as long as x is greater than or equal to 4, I won't break this. So my domain goes from 4 to all things greater than equal to 4, which means it goes from 4 to infinity, and 4 is included because it has the equal to sign beneath it. Okay? Now, range. Range we have to think about. What is the range? It's the list of all y values. So this here says y equals something. Well, what's going to happen when I take the square root of this? What kind of number am I going to get out of it? It's going to be okay, so let's think. If I plugged in a 4 here, what would my y value be? 0. If I plugged in a 5, what would my y value be? 1. If I plugged in 8 here. Okay, well, let's think about what we're getting. We're getting 0. We're getting 1. We could get 2 if we plugged in 8. If I plugged in 13, I would get 3. Right? Everything I'm getting is what? Say it. positive. I can't get a negative number out of that radical because when I take a square root, I'm saying what times itself gives me that value. So whatever comes out of it is going to be a positive number. So the lowest possible value for my range is going to be 0. That's the lowest y value. And they continue to rise forever up to positive infinity. So again, that's kind of different for us to see that without a graph, but I'm going to graph it here just to back up my hypothesis. So I've graphed it on the graphing calculator. I'm going to take a picture of it, if I can get it where I don't have a glare. And so you guys can see what it looks like. All right, so right down here is the origin, right? 0, 0. So we said it starts at 4, goes this way forever, and look how the graph is always increasing. So the y values are never going to go down beneath 0. And we know that the graph doesn't exist over here because the x has to be greater than or equal to 4. So I don't have to worry about what happens over here because nothing happens over there. It breaks the graph. Any questions? Pick a number, 1 through 5. It's 2. Pick a number, 1 through 4. It's 1. What do we find the domain to be?
Found it to be 1 and infinity.
So all values from 1 to infinity, 1 is included. That is correct because we take what's underneath the radical, say it can't be negative. So I would say x must be greater than or equal to 1. Okay, then what is the range here? So again, that's where we're that's new to us. So if I take the square root of something, what's going to come out over here? It has to be 0 or positive. So the lowest y value is 0 up until positive infinity. Again, we could graph it to verify, but essentially what's happening is that graph is just going to be moved over a little bit from our previous graph. Now instead of happening from 4 to infinity, it's going to happen from 1 to infinity. Vertical line test. You guys remember this? Yeah, everybody always remembers the vertical line test. I don't know why, but you never have to worry. So if you don't, here is how it works. I've got a graph of A, and they want to know, is this a function? Well, for it to be a function, each x can only have one y. So if I draw a vertical line, it can only touch the graph one time. But when I drew this vertical line, it touched the graph 2 times, which means this x value has 2 y's, so it is not a function. Not a function. Look at B. Is that a function? It is. Yes, a function. Any questions there? The problem is when we talk about where it's increasing, where it's decreasing, or where it's constant, we use x values to talk about that. It's like a timeline. So this graph starts at -2. From -2 all the way to 0, the function is decreasing. So you see it says it falls from -2 to 0. So from -2 till 0, it's decreasing. Does everybody see what I'm saying? A lot of people are going to say it's decreasing from 4 to 1. All right? The y values are changing from 4 to 1, but where that's happening is from -2 to 0. So we read this like a timeline. We read it from left to right. If you remember, I told you we have to read graphs like we read words from left to right. Then what happens next? From 0 until 2, the graph is constant. It's not going up or down. And then from 2 until 4, the graph is increasing. Everybody understand all that? Now, when we tell where this is happening, we always use an open interval. which means we're going to always use parentheses to talk about it. Because if you didn't, think about it 0. At 0, is the graph decreasing or is it constant? Well, it's switching from one to the other. So we don't ever include the endpoints in the increasing or decreasing of an interval. Okay, so let's look at these three. Let's look at A part. We want to determine where's the graph increasing, decreasing, or constant. So because this graph goes forever, where do I have to start? All the way over here at negative infinity. So as I approach my graph, what is it doing? It is increasing. Yes, because I see the y values are going up. It's increasing, it's increasing, it's increasing. It almost looks constant, right? But I promise you it's not. Okay? And x to the third is always increasing. So we have to for sure see it being constant to call it constant. Because again, we know with these graphing calculators, it can sometimes get a little tricky. But it's still increasing, increasing, increasing. When does it stop increasing? Never. It's always increasing. So I would say here it's increasing from negative infinity to positive infinity. Or it's increasing everywhere. It's decreasing never. It's constant never. When I look at B part, again, I have to go from forever. So when I approach this graph, what's it doing to start with? It's increasing. When does it stop increasing? At negative 1. We stop increasing at negative 1. So we would say the graph is increasing from negative infinity until negative 1. Then what does the graph start doing at negative 1? It starts decreasing. When does it stop decreasing? At 1. So we would say the graph is decreasing from negative 1 till 1. And then what's it doing? Increasing from 1 until forever. So we're going to put a union here and say it's increasing from 1 until forever. So it's increasing from negative infinity to negative 1 and from 1 to positive infinity.